couple, and simply cut out the wedge and drop it into the substrate jar. Shaking the jar afterward will help disperse the mycelium. As the mycelium begins to develop and spread, every 2 or 3 days, the jars should be agitated to mix up the mycelium further and break up solid clumps. Shaking the jar may not always be enough. Banging it against a non-resistant surface such as an airless car tire or on a roll of duct tape both work well. But be careful. Always be watchful for damaged jars. You should be looking for contaminants when each jar is handled also, so keep a vigilant eye. When mycelium is growing fast, it is important that every few days each jar is dealt with so that the substrate clumps are broken down. If jars are left too long without being agitated, the substrate may become one solid clump and difficult to use. In about a week or 2, when the entire jar is colonized, use each jar to inoculate about 10 other jars, which are prepared in the same way. To inoculate a new jar, start by checking the source jar for contaminants one last time, and then agitate it so that the entire contents can be poured. In a sterile area, or inside a glove box, carefully pour about 1/10 of the contents of the source jar into the new jar. Do it quickly and carefully. Replace the cap and shake the new jar and incubate it as you did the original. Using this method, it only takes a few weeks before you have hundreds of colonized substrate jars. At any time, a colonized substrate can be fruited, meaning it will be forced into the next phase of its life cycle, and mushroom bodies will soon develop. This is achieved in part by a process called casing. In order for colonized rye seed to grow fruit bodies, it must be cased. This means covering it with a layer of peat or vermiculite, or something similar. The casing layer provides moisture and protection for the substrate and helps initiate the fruiting process. The casing layer can be applied directly to the substrate inside the jar, or else the substrate can be poured into a tray. The casing is then applied to the substrate in the tray. Casing is popular because it lends better to large-scale cultivation than the rice flour and vermiculite cake method does. The casing layer must be a non-nutritive substance like vermiculite or pH-balanced peat moss. Combining peat and vermiculite is also popular, and pre-sterilized pH-balanced soilless mix is very good. The mix should be pasteurized or sterilized first. To sterilize it, thoroughly moisten it and place it in a canning jar with the lid on loose or in a pillowcase, and cook it in the pressure cooker for 1 hour at 15 psi. Let it cool and keep it in the jar or pressure cooker until it is to be used. Prepare a tray for the substrate to be poured into. Trays can be metal or plastic and should be sterile. It is best if they are opaque. Semi-clear Tupperware containers may need to be wrapped with tape or plastic so that light is kept out. Take a colonized rye jar or several of them and loosen up the substrate. Empty the substrate jars into the tray until the tray is full. Use the jar to pat down and crumble any large chunks. The substrate should lay out mostly even. Cover it with a thin depth of casing material. The depth of the casing layer should be about 1/4 of that of the substrate layer. For the first few days, the casing should be kept in the darkness at 86 degrees Fahrenheit, the same conditions as before. Cover the top with an aerated lid or put the casing in a humidified terrarium so the casing won't dry out. Mist the casing layer gently, once every day or so. The mycelium may grow fast, and some spots may see more growth than others. In this case, growers like to do something called patching. Patching is covering the areas where mycelium grows early with more casing. This beats back the areas of fast mycelial growth, so the entire surface can develop at the same time. Timing is critical for the next step. Here, the grower will change 3 variables to the mushroom environment: temperature, light exposure, and fresh air exposure. This will cause the mushroom culture to shift into fruiting mode. The temperature is dropped 10 degrees, from 86 degrees Fahrenheit to 76 degrees Fahrenheit, by removing the culture from the incubator. Light is introduced. A small fluorescent on a timer set for 12 hours on, 12 hours off is fine. Fresh air is increased. This is achieved by placing the casing in a terrarium where aeration is good but humidity remains high. It may be necessary to fan the casing a few times each day to remove carbon dioxide buildup. These changes should be made when the mycelium can be seen evenly throughout the casing, but before it is well established. If it is done too late, then the mycelium will overlay the casing layer, and fruits will not develop. Within a couple of weeks, fruit bodies will appear. Harvest them as you would with the mushrooms that grow on rice flour and vermiculite cakes. In order to understand why and how a genetic strain is isolated, let us first look at the natural growth cycle. When using a spore print or a syringe to inoculate a substrate, it is referred to as a multispore inoculation. This is because dozens, perhaps thousands of spores are introduced to the substrate. Each spore that germinates will develop into primary mycelia, termed monokaryotic mycelia. These primary strains will then pair into secondary mycelia strains, termed dikaryotic. Only dikaryotic strains can bear fruit. Each dikaryotic strain will have a unique genetic makeup, or genome type. These different genome types will often have noticeably different growth characteristics, some of which are known to fruit better than others. In particular, ropey, strand-like mycelium is better than solid, fuzzy types. Ropey, strand-like structures are called rhizomorphs, and these are what cultivators look for. In a typical multispore culture, there is usually the presence of both fuzzy-type strains as well as the rhizomorphic. By extracting a sample of the more promising rhizomorphic strains and using it as inoculant, growers can be assured of better fruiting potential in the end. Some growers claim that isolating a single genome strain will also reduce the chances of detrimental competition among different genome types. In order to isolate a single, secondary mycelial strain with preferable growth characteristics, growers most often use petri dishes in agar media. Agar media